Kennedy is in this class and he made a work of art. What do you guys think of Kennedy's eagle? Pretty cool?
Mr. Kramer?
Yes, sir.
I think there's something wrong about the coordinates because if you look in the picture in the top left, it's like it goes all the way to the end of the paper, like the bumps at the end with like the color underneath them. But like on the coordinates, it only goes like to like right here.
Well, you know what I'm going to do, guys? I look at this point right here, and I'm going to say that point is 620, is it not?
Mm-hmm.
Do you guys see it? So let's find 620 in our picture.
I see it.
Do you guys see it right there?
Yep.
Now, the point after it is 317, which he did perfectly, and then 250. But the point before it is 920. And guess where you went, Kennedy?
What?
You went to 9. Anybody can say it.
19.
That's right. So Kennedy, if you had gone to 920, it would have been straight across.
Oh.
Isn't that cool that we were able to find the solution to that? And I'm really proud of you, Kennedy, that you asked that question. Only great mathematicians will ask good questions. The next one I want to show you is Kennedy's Diplodocus. And I got to tell you, I didn't think dinosaurs were still alive, and I'm starting to doubt it right now. This is Alexander's, and this is one of my favorites, guys. Ava created a beautiful Easter egg from coordinates, and I'm going to put this on my website this weekend. So on Saturday, you can get these coordinates and make an Easter egg. And Chris, your Bart Simpson is beautiful. Can you please send that to me? Jonah, what do you have to add, buddy?
Can I show something that I made on here?
Right now, absolutely.
Okay. So, I want to show my Abraham Lincoln.
Oh yeah.
Can everybody see Jonah right now?
Because they're all downstairs.
Oh my God. Jonah,
Wow.
Jonah, I gotta say something. Abe Lincoln never looked so good. Just so you know, true story, Abe Lincoln was not a very handsome man. And he only took a couple of 2 or 3 really good photos. But that, Jonah, I think is one of the best. Drew, what about you, buddy?
I made a Pepsi logo.
Oh my God, that's so cool.
Where?
That's so cool. Guys, do you think you could create a new logo? What about you, Hayden?
Ooh.
Hayden, hold yours. Oh, Hayden, yours is awesome. Now, everybody, I'm going to show you a few more. We have Hayden's, Hayden Schmidt did a sailboat. Oh, and I thought I had some other coordinates. No, that wasn't it. I think Hayden from this class, I think you sent me some coordinates. I have to get that in my document. Okay, I will do that. I will do that. Now, I want everybody to look at the screen. Who can raise their hand electronically and tell me what is different about what's going on in this picture? I'm going to start with you, Jesse.
I know.
What's going on here, Jesse?
The inside of the eye, the black part, is bigger than the other one.
Oh my God.
Exactly how this is happening.
Can anybody tell me what that means? Say it out loud, Carter. Go ahead.
I forget.
Okay, what do you think, Drew?
So basically this person is like looking through a hallway and half of it has lights off and the other half has lights on. And so her eye that has the larger pupils inside the part that has a darker section, and the one with the smaller pupil is inside the lighter part.
Well, Drew, you are right. And everybody, the word is pupil.
Yep, pupil.
I just drew the diameter of the large pupil, and I'm going to draw the diameter of the small pupil. Now, I think the coolest people in the world wear glasses. That's just me. I'm a big fan of Benjamin Franklin, who, of course, invented spectacles. and I wear spectacles, and I love people who go to the eye doctor. And when I go to the eye doctor, the eye guy puts these drops in my eyes, and it makes my eyes dilate. Everybody go like this. Dilate, bigger and bigger and bigger and bigger.
Till they get
Now,
big.
does anybody know why the eye doctor dilates your eyes? I have Teddy here raising his hand, but you'll have to unmute yourself, buddy.
Because I think the eye drop, like the the pimple has to get like bigger.
Why does the pupil need to get bigger? What is it
I know.
about the pupil? Wait. I want to hear from Chris. Go for it, Chris.
So you can see much better.
Ah, if the doctor gets a big pupil, she can go in with a magnifying lens and see to the back of your eye. At the back of your eye is some pretty cool stuff. It's called a retina, an optic nerve, and then there are blood vessels that bring blood to your eye, and he or she can see whether your eyes are healthy or not. Now, here's the challenge question. By the way, I have 2 raised hands. I have Gabby, who needs to unmute herself and also turn on your video. And I have Jesse as well. Now, Gabby, I'm trying to unmute you, but there you go. Go for it, Gabby.
We can't figure out, my video is on, but we can't figure out why, I can't see.
Gabby, here's my recommendation, Gabby. My recommendation is to leave the meeting and come right back, and that usually fixes everything. Now, I want you guys to tell me, this is the big challenge. If I took the little pupil and I wanted to make it bigger to look like this pupil,
Oh, I know.
how much bigger do you think it is? And I want you to send me a chat right now about what's called the scale factor. How many times bigger is the big pupil than the small pupil? So let's say you think it's, I don't know, 100 times bigger. You would say times 100. Of course it's not, but that's what you would say. So how much bigger?
How do you rate the times?
With an X.
Oh, I did 3.
With an X. And Gabriel, you might want to unmute yourself, Jonah as well, and Drew.
Where's X though? Oh, 3X.
And so what do you guys think it is? Say it out loud on 3. 1, 2, 3, go.
Times 3. 10.
Times 3.
Guess what, guys?
3.
You did it. You did it. And now do this for me. What if you did it from the big eye down to the small? What would the scale factor be then? Now, this is a really hard one. I don't want anybody saying it out loud, but it's actually a fraction. And I want you guys to think, if the scale factor from small to big is 3 times, then the scale factor from big to small on 3 must be what? 1, 2, 3?
1/3.
1/3. 1/3.
Guys, that is amazing. That is truly amazing. This is a scale factor getting larger of 3 and getting smaller of 1/3. And I'm really proud of you for noticing that. Now, on this page right here, we have a knight. Now, this knight right here is the original. He has a scale factor of 1. Do you know that right now I have a scale factor of 1? I am 100% of me. What is your scale factor right now?
1.
You are
1.
all a scale factor of 1. Now, I want you to look at your parents, or if they're not with you, imagine what they look like. They are a scale factor like this.
They're a 0.
What do you think their scale factor is compared with
2.
you?
A 2.
2.
Well, guess what? Guess what? If this big knight right here were your parents, they would be a scale factor of 2.
I knew it.
Now I want you to think of your little baby brother or sister.
I don't have one.
What? Well, of course, you'll have to imagine it then. What would the scale factor be for your brother or sister? From 1 to what?
0.
On 3. 1, 2, 3.
1.
0.
My brother's the same age as me, so 1.
0.
Oh,
1
so
half.
for your brother, it would be 1. But for a baby brother, and Jesse, you can say it out loud.
It's 0.
Ooh, wait a minute. Do you know what happens with the scale factor of 0? Would you like to see it? Don't get scared, but here we go. Are you ready?
Yep.
A scale factor of 0, Jesse?
Nothing.
Smaller and smaller and smaller,
Where?
smaller and smaller and smaller until it disappears. Now, we can't have that, can we? So it is, whoever said 1/2 is exactly right. And guys, if you notice, look at the height of scale factor 1. Isn't it twice as big as scale factor 1/2? And this is how we dilate. We dilate bigger or smaller. Now I want everybody right now to go to page 4 in their packet. Go to page 4 and go to the bottom of page 4. Now, I'm going to tell you the scale factor right now of A to B. B has a scale, well, if A has a scale factor of 1, and I'm going to tell you that B has a scale factor of 2, and C has a scale factor on 3, 1, 2, 3.
3.
No, it's a scale factor of 4. And now you should say, Mr. Kramer, let's prove it.
Oh, I know exactly what it is.
Yeah.
Hey, Drew, tell me how I get from the segment via point 23 in triangle A to segment 812 in triangle C. Drew, tell me how to get there.
And that's not what I meant by like I know what's happening. So like it's like 1 plus 1 is 2, 2 plus 2 is 4.
So how can I get from 2 to 8? Gabriel, do you know? Carter, Olivia, can you tell me?
Oh, I know.
And Gabriel, go for it.
Oh.
Gabriel, you are muted. You are. There you go. Gabriel, you have the floor, buddy.
What, me?
Tell me how you get from 2 to 8. Actually, why don't you think about it? Carter, go for it.
2 times 4.
Guys, we just multiply it by 4. Who can tell me how to get from 3 to 12? Who can do it? Raise your hand. Jonah.
We go 3 to 6 to 12.
That's right. And who could tell me how to get from 5 to 20? Olivia, how do we do that? Olivia, you just muted yourself, honey.
I don't.
You gotta unmute yourself. Go for it.
You go. 5 times 4.
Oh, that's right. Beautiful jobs. And James, who is awesome. How do you get from 10-2 to 24? How do we go from 10-2 to 24?
24. 10,
How
2.
do we go from 10-2 to 24? What do we have to do to get from 10-2 to 24?
10 to 24.
10 to 20 and 2 to 4. What do we have to do?
Multiply 10 plus 10 equals 20 and 2 plus 2 equals 4.
Exactly. So it's again times 2. Sam, you have your hand raised. Go for it, buddy. Oh, but you're muted. Go for it. And Gabby's muted. Sam, you just muted yourself. I'm trying to unmute you. There you go.
Wait, what?
Go for it, Sam.
I accidentally raised my hand.
Oh, okay. Try to work on that, Jack. I'm trying to unmute you here. Okay. Now let's move on. Everybody, go to page 5 right now, and I want to show you something really cool. How many of the small triangles, triangle A, can fit into triangle B? Who can see it, guys? 1, 2, 3, and
4.
4. How many of A's can fit
4.
into C? Don't say it out loud. How many of triangle A can fit into triangle C? So I want you thinking about that. You can send me a chat with the answer. Send me a chat with the answer. It'd be really cool. And I'm looking for your chats right now. Whoa, Jesse, you nailed it.
16.
Whoa. Now, Gabriel, I want you to watch this.
Let's see.
Gabriel, do you see how 4 go there, and 4 go here, and 4 go here, and 4 more? Do you all see how it's 16 now? Isn't that cool, guys? Do you see that? So
It's 4
just
times 4.
really, really nice. Who said 4 times 4? Very cool. 4 times 4 is exactly how you get to 16 triangles. Really, really cool. Okay, everybody go to page 6 right now. Everybody go to page 6. And what I want you to do is I want you to, and I'm going to mute everybody because there's a lot of shuffling of papers right now. And we talked about the shuffling of papers when you go like this and know all the noise it makes. Now, I want you guys to go to point 5, 3. And I want you to double the 5 and double the 3. And now put your pencil mark at 10, 6. So double the 5, double the 3, and put your point at elevator 10, floor 6. Do the same thing with point 9, 3. Double the 9 to 18, double the 3 to 6, and put the cursor at 18, 6. And then take your marker and make a line from 10, 6 to 18, 6. And you have the base of a huge dilation of 2. And I want you to start doing a scale factor of 2 right now. And if you have any questions, you need to raise your hand electronically. So I'm going to take you through this while you guys are muted. The first point I'm going to look at is 5, 4. I even write down 5, 4. I double it, and I get 10, 8. Now I find 10, 8 on the graph. I take my ruler and I make a beautiful line. If anybody has any questions about that one thing that I just did, this would be a great time to raise your hand. It shows a lot of strength to raise your hand if you have a question. And if you don't raise your hand, that's not going to make you a great mathematician if you don't understand. So, James, I'm calling on you. Go for it. You'll maybe have to unmute yourself because I'm trying to unmute you and can't do it. There we go. Go ahead, James.
Wait, where do you make the straight line to?
Well, James, remember I said that we started out at 0.54. Do you see 0.54 on the original night? Do you see it?
Yeah.
James, can you double 5 and double 4, please?
10, 8.
So do you see, James, that 0.108 is elevator 10 and up, 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 up to 0.108? Do you see it?
Yes.
James, do you see it?
Yes.
Okay, so your job is to
Oh.
make a line from 10.6 up to 10.8. All right, great question. Anybody else have a question? Go ahead and raise the hand. Otherwise, go to the next point. 6.5 becomes 12.10. Gabby, go for it. Gabby, I'm trying to unmute you. You may want to help. There you go.
What is a scale of 2?
It means, Gabby, and that's a great question. If we are working with 0.65, do you see 0.65 that I just hit
Yes.
on the original night? Do you see it?
Yes.
Now, Gabby, a scale factor of 2 means we're going to double the 6. What do you get?
12.
Okay, 12. And double the 5, what do you get?
10.
And so therefore, this point, Gabby, right here is 0.1210. Does that make sense?
Yes.
So now, Gabby, go to the next point, 6.6. Double the 6, and you get what, Gabby?
12, 12.
You got it, girl. Now make a line to 12.12. And now, Chris, go for it.
I didn't understand because I got all the way up to 12 right here.
You mean 12.12?
24. You can't really see it.
So
I got.
yeah, well, all you have to do is tell me what point you started with and what point you tried to enlarge to.
I started with what you did, and I got all the way to 3.6, and I multiplied that.
Hold on a second. I'm going to go right now to 3.6, which is not on the scale. There's 3 6s right over here, Chris.
Oh.
Ask your question again. Did you mean 6.3? Now, 6.3 is right over here. Okay. And let's see if I can make this go away. Okay. So when you are on, so Chris, you haven't yet told me where you're struggling because you gave me
Oh,
3 and
never mind. I messed up.
Did you figure it out, buddy, on your own?
Yeah.
Oh my God, that is the best. And I don't see anybody else's hand raised, but you guys better raise your hand if you have a question. Really, really important to do. And Jesse, go for it.
I think I'm done with this horse thing.
Okay, so guess what, Jesse? You have a challenge. If you're done, Jesse, your challenge, and anybody else can do this, but not until they finish scale factor of 2. I want you to do scale factor on the same page of 1/2. That means that you have to cut every number in half. Okay?
Oh, okay.
So go for it, Jesse. And I'm looking for good questions, guys. I haven't had any questions while you've been working on this. And I really love when you guys ask me great questions. because I learned so much. Teddy, are you trying to raise your hand, buddy? Do it electronically next time. I could see you faster. Go for it.
When we're done with, if we do finish the second one, what do we do?
Do you mean if you finish the scale factor of 1/2? Teddy, did you already do that?
No.
Okay, so Teddy, Jesse just asked me what happens when you're finished with scale factor of 2. I want you to do scale factor of 1/2. And what that means, Teddy, is that you have to cut every point in half. So if you have 0.48, it becomes 2.4. If you have 0.26, it becomes 1.3. Does that make sense? Yes, Teddy?
Yeah, it does.
Okay, great, great. Get working on your scale factor of 1/2. Kennedy, go for it, buddy.
It said, so when you go to point 10, 12, you said double it. If you double it, that would be 2024, but 2024 is like way up here.
10, 12, 10, 12. Okay, now, Kennedy, this is point 10, 12.
Yep.
So you're not going to be doubling that. That was doubled from 5, 6, which was right over here. So are you talking about point 9, 11, Kennedy? Are you talking about point 9, 11 instead?
I think I might. Yeah, I think I was.
Because if you double the point 9, 11, you get what?
1822.
You're the man. That's it. And Kennedy, that was an awesome question. Jesse, go for it.
I don't get this the half thing because
So tell me which point you're working on, buddy.
the second one you give after the big one.
You have to give me the point on the original blue so I can help you cut those in half. Could you please do that?
So I did a little bit of them, then I start doing something wrong because because they have this one unit, then you have to cut the unit into half. So I don't know how to do that.
If you give me the point, like for instance, if you're working on 0.48, say, Mr. Kramer, I'm working on 0.48. If you're working on 0.65,
like I'm working on 0.53. I don't know how to do half of it.
well,
That's
guess what? You're about to find out. So if you go to 5.3, and Jesse, I want you to watch what I do now. I'm gonna cut Mr. Kramer in half. Ready? Here we go. Kramer divided by 2. I'm gonna cut Jesse in half. Jesse divided by 2. I'm gonna cut Smiley Face in half. Smiley Face divided by 2. I want to cut 5 in half. 5 divided by 2. 3 divided by 2. So guess what you have? 5 halves, which is 2.5 right here, Jesse. And 3 halves, which is 1.5 right here. And locate that point. It will be right at that point.
Oh, thanks.
And you're welcome. So Teddy, you're also working on the half, I know. And Teddy, was that explanation helpful for you to find out how to cut things in half? Okay, great. Now, guys, you may not finish this before we move on. So if you're not finished, you'll finish it during the week and send it to me. Now, I want everybody to please go to K for Kramer on page 8. So everybody go to K for Kramer on page 8.
Oh,
Now, guys, we are going to do something really, really special here. I've just unmuted everybody. We're going to do a scale factor of 3. Everybody write that down, but not so big. Just circle the 3. We're doing a scale factor of 3. And what that means is instead of doubling, what are we going to be doing to every single point value? Say it out loud.
triple. Triple.
Tripling. So everybody triple 1, 2. Go. Triple the 1, 2.
Okay.
Come on 3, 1, 2, 3.
3, 6.
Oh, there it is. 3, 6. Everybody triple 110. 110 on 3. 1, 2, 3.
30.
20.
Oh my God, guys, can I even reach 330? I'm gonna have to make my screen a little bit smaller to do that. Guess what, guys? You're now gonna connect 330 and 36. So everybody gets started with the biggest dilation so far. This is the biggest dilation we've done yet. Now, next week, I hope you remind me to tell you a story about dilations, because I once dilated something by a factor of 373.
Whoa.
Now you have to say, Mr. Kramer, you said that you were going to show us a dilation of 373. And so I am going to try to give you an example of that if I can. So we're going to have some fun. Who wants to raise their hand to ask me a really good question about enlarging the K to a factor of 3? James, go for it.
Do you double 330?
Oh God, if you double 330, you would be creating from the little k a scale factor of 9. No, we're going, James. The next point, James, is going to be this point right here. James, tell me what that point is.
3, 2 right now.
And I want you to triple both coordinates, please.
6. What? 6.
I don't get 6. 3, 2. 3, 2. 3 gets
9.
triple. 9 what?
9, 6. 9,
Dot
6.
means- Now make a little dot at 9, 6 and take your ruler and make a beautiful horizontal line. And you have just reached the next point. So, Jack, can you get working, please? You get working. All right. And Jesse, I don't see you anymore. Jesse, can you
Here.
Can you undo your virtual screen, please? Because virtual screens make people disappear, and that doesn't work for me. Okay? Who wants to ask the next great question about tripling? So I would
I
love
think
to
because
get.
of my iPad position.
Got it. Thank you, Jesse.
1, 2, 3,
Ooh, this is a good one.
6, 9. Again.
3, 5 became 9, 15. That was a cool one. 5, 2 must become 15, 6. Wow.
Right here. Okay. So there. Just
7, 2. Who can help me out with 7, 2? I'm having a little trouble. Can someone please help me out
no.
dilating 7, 2 to a factor of 3? Who can help me with that one? Raise your hand if electronically, please, so I can see it electronically. Oh, Gabby, go for it, kid. Help me out there, Gabby.
You would get 21 6.
Wow. Did anybody else get the same thing? Give me like a little, yeah, I got it too.
Yeah,
That's
I
great.
got it too.
Joni, you got that, buddy?
Yeah.
You got that, Jack? Hey, Jack, can you turn off virtual screen, please? I'd appreciate that. It's a little distracting for me because I can't see you very well. So, Gabby, 21-6 is all the way over to the right. I was really having trouble with that until Gabby, you helped me out. So thank you. Now I need to do 4-6. Whoa. Who wants to take 4-6? Drew, Olivia, you want to take that one? Gabriel, you want to take that one? Sam, you want to take that one?
Okay.
Who wants to take that one? I need to do point 4-6. Gabby, well, Gabby, you had the last one. Jonah, I want you to practice raising your hand electronically because you've been raising your hand when I look over, but it's easier for me to see. Go ahead, Jonah.
Wait, what was the coordinate again?
It's right here at the cursor, 4-6.
4-6. Oh yeah. That would be 12-18.
Gabby, do you agree with that?
Yes, that's what I was going to say.
Awesome, awesome. If everybody else got it, then you give that to me next time. So 12-18 is right up here. Whoa. You know, that even looks correct, Jonah. Thank you. Now, guys, I'm getting pretty close to the end here. If you are, you should start doing a dilation of 2. You should start doing a dilation of 2 on the exact same page. And it's a lot of fun to do that because you make images on top of other images.
5, 10 is what?
And it's really cool.
15 more.
Okay, 2-4. I'll start at 2-4. Okay.
Wow, that's really good.
1, 2, 3, 4. Good.
Now, can anybody ask me a good question about any of these points? Now, remember, your next job is to do a scale factor of 2. So 1, 2 becomes 2, 4. And I'm just going to give you guys a few more minutes, and then we're going to move on to one more challenge. Don't worry if you're not done, because that just means that you get to do more during the week.
Awesome.
8, 12.
Yeah. 9,
18.
Yeah, right here.
10, 15, 16, 17. Good. 1, 2, 3, 4.
I keep raising my hand 2 times and I got the.
Is somebody raising their hand that I can't see?
I choose one.
Well, I think you might.
No, 12. What's the point? What's
the point? What's the point of dilation? There's a lot of good points to dilation. Okay, guys, can everybody put their pencils down for a second, please? I want everybody to look at what Mr. Kramer did, where I dilated my K to a scale factor of 2, and that's the green, a scale factor of 3, and that was the red. Now, for all you crazy mathletes like me, you could do a bonus scale factor of 1/2. And that would be really, really cool. Now, everybody right now, please go to page 10 in their packet. Now, page 10 is probably the most difficult one that you've done so far. Some of you started embarking on the world of 1/2. Who can say out loud the point that I am circling right now? Please raise your hand, raise your hand, raise your hand. On 3, 1, 2, 3, go.
420.
20.
All right. Now, everybody, cut 4 in half, go.
2.
Cut 20 in half, go.
10.
What's that spell?
210.
210. Now do this one. This one is 820. Cut 8 in half, go.
4.
Cut 20 in half, go.
10.
What's that
10.
spell?
6.
What's that spell?
410.
410. So your job right now is to make your first line between 210 and 410, and that is the beginning of your dilation of 1/2. Go for it, Carter. Oops. And Carter, you're going to have to unmute yourself. Go for it.
Uh,
Oh my God, that's so good.
Carter, what's your question, buddy?
oh, I forgot to put down my hand.
Oh, okay, Gabby. Gabby, you had a question, love. Go ahead.
Should we finish them right now?
No, you should be working on the M right now, because we've got 10 minutes to cut the M in half. It's kind of like going from you to your baby brother, or going from your parents to you. And so M for mathletes, we're going to make it a lot smaller. 4-2 becomes 2-1. And guys, I hope that I'm going to get good questions from you on this one, because this is way harder than anything we've done so far. 8-12. Somebody raised their hand. Yes, sir, Jesse.
I'm done.
Can I see it, please?
Yeah, I did. Yeah, sure.
Oh my God, that is beautiful. Now, Jesse, are you ready for a big challenge?
Yeah.
Don't get scared. I want you to do a scale factor of 1/4.
1/4. Okay.
That means that everything you're going to cut in quarters. So, Jesse, let me give you an example, Jesse. You ready?
Uh-huh.
If you have the number 412, cut 4 1/4, and what do you get?
2.
No,
2 6.
cut it in half.
Cut it in half.
No, I want you to cut it in 1/4. I want you to divide.
Oh, equal 1.
Yep. And then divide 12 by 4. What do you get?
12 by 4 equals 3.
That's it. So now
So
go from the big to a scale factor of 1/3.
1/3.
Yep.
Wait, do I do 1/3 or 1/4 first?
Oh, I'm sorry. I misspoke. You were listening well. I want you to do 1/4.
Okay.
That's going to be a little bit easier than 1/3.
Yeah.
And Jack, go for it.
Let's see. One.
Go for it, Jack.
I finished.
Now, Jack, I want you to look at the red M that you made, or the whatever color you made, and I want you to cut that one in half. Okay, Gabby, what you as well? You're finished.
1/4.
No, but I don't get which way we're going on the M. We started on the big.
Wait.
Now I don't get where we're going.
So right now, Gabby, I'm looking at 16/12, and if I cut that in half, I get to 8/6. Now you have to tell me the last point you did on the big,
Nope.
and I can help you find your place.
Oh my gosh. Holy moly.
So Gabby, you actually have to tell me where you are on the big M, and I'm gonna help you find your way.
9. So 1, 2, 3. 1, 2, 3.
Yeah.
No.
8.
How do you cut
Wow.
9 in half?
And Jesse, you gotta be quiet for just a second. I'm gonna mute you for a sec. So go ahead, Gabby.
On the big M, I was at 8/12.
Okay. 8/12, Gabby. Did I go to the right place?
Yes.
Now, if you take 8/12, Gabby, and you cut that 8 in half, what do you get?
4.
If you cut that 12 in half, what do you get?
6.
What's that spell?
4, 6.
That's it. So that's your next point, kiddo. That's your next point. Yes, sir, Jesse.
I don't know where to start.
Well, you pick the point on the large M, and I will help. You know what, Jesse, I have a better idea.
Mhm.
Don't look at the first M, the big M. Look at the M you created and do a scale factor of 1/2. So look at the M you created, use a point on that, and just cut it in half.
Just cut it in half.
That's right.
Just cut it in half.
Okay, now I want everybody right now to do me a favor and put pencils down. Everybody put pencils down, and please look at me right straight in the eyeball. All right? Now, one of the things you guys are going to get to do, and I'm just going to mute everybody now while I tell you this. The most fun that I have is to watch things getting bigger and smaller. So one thing that I like to do is if I go here and I grab this chess piece and I grab it and I put it on the page. Now I can take him. It's like with your phone when you swipe out and swipe in. I can dilate to a factor greater than 1. I can dilate to a factor less than 1. Never 0. And if you go to infinity, you know what that means. I want you to have fun swiping out and in on your iPads and on your computers. Those are all special dilations. Now, I want you to look at my favorite page. My favorite page has nothing on it. And that's because you know that I love to create my own drawings. Now let's help me right now. What would be a really good letter to do? And I'm looking at your names. You know what's a really hard letter to do? Is G for Gabriel. So I'm gonna try to create a G right now. I don't know if I'm gonna be successful. Gabriel, how am I doing right now? And Teddy, go for it, Teddy.
My mom has a Zoom meeting. Can I click off?
Oh yeah, buddy, of course you can. Of course you can. I'll see you next week. And Teddy, make sure you send me your diagrams that you create. All right, buddy?
Okay.
Thanks. Okay, so I'm trying to make this G, and I'm really not doing very well. But how am I doing now? Am I doing okay now? And you guys can tell me, I'm going to unmute everybody. How am I doing now?
Pretty good.
Pretty good. A little more diagonals on the sharp edges.
Oh, you know what? I think you're right. It's not the best G I've ever made, but you know what? It's not terrible. So if I take that G, maybe I could dilate that G to a factor of 2. But beware. What is the danger about dilating this to a scale factor of 2? Who can tell me that they see some danger here? Hayden, do you see any danger? What's wrong with this, Hayden? Hayden, like what's wrong with that point that I have here, like 1511? What's going to happen when I double the 15 and when I double the 11? Who can try to help me out with that one? Who can say double 15? Say it out loud. Go.
30, 22.
30, 20.
30,
22.
You guys see that the paper ends at 21? Now, with your margins, you may be able to go out to maybe like 23, but you got to be careful. If you want to do a scale factor of 2 or 3, you're going to have to make your original drawing a lot smaller. Do you guys understand that?
Yeah.
Now watch what happens with my G. Are you ready? Are you ready? Here we go. Did I just dilate it?
Yeah.
Now, you should know that I actually did it. It actually changed. Now I'm going to dilate it to a factor of 2 and then 4. So if you start nice and small, you could dilate it to a factor of 4 if you like. All right, let's start by counting by 4 right now. And we're going to start with the number 36, negative 36. Everybody on 3. 1, 2, 3, go.
Negative 30.
Negative 32.
32.
Going.
Negative 28.
Keep going.
Negative
24.
24.
Negative 20.
Negative
20.
Negative 16.
Negative 16.
Negative
12.
12. Negative 8. Negative 4.
Don't ever say
Never say
Zero.
negative 0.
2,
2.
4, 6, 8. Do the read of math, please. Math, please. Oh, math. Guys, I will see you in just about, let me see if I can figure this out, 166 hours and 59 minutes. 166 hours and 59 minutes. And
58.
oh, now it's 58. Oh my gosh. And oh, Gabby, did you have a question for me?
Shut off. You can.
No? Okay. Everybody go dilate big, dilate small, dilate big, dilate small. Now dilate 0.
Bye.
This is dilate 0. Goodbye.